Hi, I'm Dylan Taylor, Chairman and CEO of Voyager Space Holdings, and I listen to the Cold Star Project.
Hi, I'm Dr. Gordon Ressler, the president and founder of Robots in Space. And if you want to get the latest in space technologies and business, listen to the Cold Star Project.
Hi, I'm Dr. Morba Jah, astrodynamicist, space environmentalist, and associate professor of aerospace engineering and engineering mechanics at the University of Texas at Austin. And I listen to the Cold Star Project.
I think people in the space industry are pretty used to that. No one, when I interviewed at BlackSky, no one seemed surprised that I'd kind of had a variety of experiences applying to other jobs outside of space sciences. Like if you apply to a job at like NIST to be a chemist or something like that, people kind of look at you and they're like, why have you done all these weird things?
We're back with another episode of the Cold Star Project. I'm here with Bryne Hadnott, and she is currently working as an image processing engineer for BlackSky, which I thought was cool. That's kind of a observation constellation up there, and we'll talk a little bit about that. But she's got quite a laundry list of accomplishments here. She's a past graduate student researcher at NASA JPL, has a master's degree in planetary science from Johns Hopkins, worked on a doctorate at Cornell and then Johns Hopkins, so big educational background there. This is interesting. A research assistant at the Gunn Institute of Ecological Economics. Those two words do not fit together in my lexicon. Well, I will add an extra question about that because I know about one and the other, but not both together. And has her undergrad degree in planetary science at Washington University in St. Louis. So what's it doing there? Why isn't it in Washington, Bryne? so cool. Thanks for being here.
No problem. I ask myself that question a lot.
So as far as I know, there's no career path laid out for scientists who want to work in the space field. We were just talking before we started here. It's like, oh my gosh, to be in space in the space industry, you must have a third eye or something like that, right? So what I've seen is like you kind of make it up as you go. And so what have you experienced and learned in the process of figuring this out for your own situation, your own career?
Yeah, planetary science and space science in general is such a weird field because it requires you to learn all of these disparate things. So like as an undergrad, studying planetary science at WashU, I took geology classes, I took GIS courses, but I also took like environmental ethics, and I had to learn stuff about astronomy and planetary formation and chemistry and how to run, a particular spectroscopy instrument. So yeah, I think all of the skills you learn, like collecting data, analyzing data, interpreting data, dealing with these weird, incomplete data sets, having to kind of pick up new instruments really quickly, is what my experience in planetary science has been. And it's great because it's so applicable to all these different fields. I think that's why my path is strewn with a lot of strange things, because I've ended up using these skills. The Gund Institute of Ecological Economics for looking at crop change in sub-Saharan Africa, and then looking at organic chemistry on Titan. And now my job is developing algorithms to process images that we take from space. So
Right.
The grab bag of stuff for sure.
Have you had the trouble with your resume? I did in my past because I kept going back and forth between sales and marketing jobs and operations jobs. Or I'd be a factory manager one year and a sales guy the next. And like, do people go, what are you? Or have you managed to position yourself properly where they can figure that out?
That's a really good question. I think people in the space industry are pretty used to that. No one, when I interviewed at BlackSky, no one seemed surprised that I'd kind of had a variety of experiences applying to other jobs outside of space sciences. Like if you apply to a job at like NIST to be a chemist or something like that, people kind of look at you and they're like, why have you done all these weird things?
Very cool. Okay.
Yeah, I think in space, people are used to it.
Okay, so for those folks listening and watching, if you have a varied background and you're wondering, can I fit into space? Yeah, there's a good chance. There's a good chance. All right. So
Very used to it.
in the summer of 2012 at Caltech, you were a research fellow and you were doing something with Mars-analogue rocks. So rocks that look, act, smell like they're from Mars. What did you do and what did you learn from that experience?
Yeah, so let's see. I was characterizing a suite of Mars-analogue basalts. And just analog means that these basalts have a similar chemical composition and might have been weathered in roughly similar conditions to Mars. So these basalts are from San Carlos, Arizona. They have been in a desert for millennia, experiencing very little rain and just kind of minimal weathering, which was roughly similar to kind of the basalts that we were seeing on Mars. So my research advisor there was Bethany Ellman, another former WashU grad, which is, I think, kind of how that connection happened. And we were interested in learning about the degree of weathering on the basalts. So how they've gone from looking pristine to these kind of weird, red, ruddy, rusty looking basalts. And kind of out of that, I learned 3 really key things that I think kind of set me up for success later on. So I learned how to set up a good research question, which was more involved than I thought, how to use different complementary methods to characterize a sample, and then finally, how to write it like a peer-reviewed research paper, which is kind of different from things I've written in the past. So yeah, we were characterizing the suite of basalts, and we wanted to understand how the spectra of the weathered basalts differed from the spectra of the unweathered basalts, and then use the lab spectra to look at spectra from orbit from XRISM, which is on the Mars Reconnaissance Orbiter, and it looks at the hyperspectrometer. And it has all these different bands where it looks from the visible to the near infrared and observes spectra of Mars, which is mostly just lava rock basalt. So we had this, like, we call it the potato masher. It's just this box with a fiber optic connected to it, and there's like this potato masher at the end with a light and another fiber optic cable, and you just put it onto your sample and you get a spectra from it, from the light reflected back from your sample. So through doing that, and kind of through looking at the spectra, kind of bitting the spectra based on this is very weathered, this is not so weathered, we kind of started asking more questions to understand the data that we put there. Like, why were we seeing new dips, new bands, new chemical fingerprints in the more weathered spectra? Shouldn't the weathered spectra have less stuff in it? Why do the weathered spectra have a totally different shape? And then kind of once we started looking at these questions more through the spectra, we started looking at all these other complementary methods that could help us determine more about the mineralogy and the elemental composition. So the research question kind of shifted, during that process of analyzing the data from, it's just going to be spectra, we're just going to use lab spectra to like corroborate what we see from XRISM, and it became more like, what is the mineralogy? What new products are actually being made? Has anyone imaged these before? And then that kind of led to using complementary methods. So I ended up doing some X-ray diffraction and some electron microscopy, which were both really cool. X-ray diffraction, you just bombard a sample with X-rays and you look at the diffraction pattern that arises from it. And then electron microscopy, you take a thin slice of your mineral, coat it in carbon, and then bombard it with electrons. And the reflection of the electrons is based on the elemental composition. So iron was very bright, something like aluminum was a little bit less bright. And it was cool to learn like all these different ways to prepare the sample for XRD or electron microscopy, how to clean and interpret the data, because looking at spectra from a Vis-near spectrometer is different than looking at a readout from XRD or electron microscope. And I really enjoyed that, kind of bringing together those complementary techniques and kind of investigating the mineralogy. So we ended up getting images of these protoclays that were being formed on the basalt, which was really cool. Kind of for the first time in a Mars sense, kind of really understanding what happens to basalts when they're weathered and what those minerals that are being formed kind of look like from an electron microprobe. And then after all that happened, it was time to write And I'd written a short paper, for the end of the summer research program, and like another longer one for the senior thesis, but the peer-reviewed paper was very different. It involved a lot more storytelling, I think, than I expected. It was less focused on just, here's what I did and here are the results and take that as you will. And it was more focused around, why did you do what you do? And kind of that chain of events I was describing before, like you were looking at spectra. How did you start shifting over here? You were looking at XRD. How did that lead you to this? And kind of connecting all of those things together and then making a cohesive kind of research story. It was almost like journalistic in a way. And then, yeah, we ended up publishing that paper in 2017.
Wow. So it took a while from the time of doing the research, like 5 years. Wow.
Yeah.
You mentioned at the beginning about the idea of setting up a good research question, and that it changed as you went along. And I've done some research on academic writing myself, where how you do this and the fact that you have to have your thinking all done beforehand before you start writing that peer review article makes things so much more complicated. So what does it feel like, I guess, or what do you do when you realize, okay, the original research question I set up is no longer good, like I need to switch that up? It might help somebody.
I guess yeah. Think about that for a second. Yeah. I guess what you do is just you stay open, you stay loose with it. At first I thought, oh my gosh, like this is the end of the world. I messed up. I have to throw everything out and start over again. And my advisor Bethany and also Brad Jolliffe at WashU were both like, hey, don't do that. Please don't throw out your data. It's fine. We just need to kind of look at it in a more holistic, complementary way. And so we ended up kind of, taking a step-by-step approach. Like, okay, the spectra, what does this DIT mean? There's an iron oxide, but it's iron 3, not iron 2. That's interesting. What did the mineralogy say? Oh, there's more oxidation in this sample than the other one. Does that correlate for all of the samples? And then just making plots and correlating different things. Okay, this band meant iron oxide, we saw it. This other axis means the amount of iron oxide that we measured in the sample from, electron microscopy, or we also did some mass spec. Do those things correlate? And we found that they did, and then that kind of led to more questions along the way. So yeah, it's an iterative process. I think I would encourage anyone to just iterate, just keep thinking about it. You'll figure it out.
Okay. So realizing it's an evolutionary process and you're not going to do a clean question answer, probably like a thesis sort of thing from the beginning to the end. And kind of the impression that I'm getting is like, okay, we've got this data. It's not exactly what I wanted, but I guess I have to live with it. This may not be the best data in the world, but it's the data we've got. This is Jason Kanigan from Cold Star Tech, and I'm excited to share with you a new offer from Cold Star that we are bringing out to help both space founders and venture capitalists who fund space companies. And it's on two levels. The lower level is a VC who is looking at possibly funding a space company, but they just don't get it. Right? And a lot of tech founders want to come out and create some sort of technical capability, but they do not understand business. And so you'll look and you'll go, where's the customer here? Where's the business model? And they'll go, but I want to make rockets or something, right? And it's really cool. Well, that, as we know from the dot-com era, is not a viable business model. And so you bring us in. We've got great technical expertise on the space side, folks who have done this sort of assessment before, like our technical engineering advisor, Dr. Rick Fleeter, myself in the process engineering field, plenty of other people with brains to look at this problem so that you don't have to blow your brains out trying to figure out how to make this work. And on the company side, it's a benefit for them because we will show them the roadmap to how you're going to get funded, how you will want to fund them, what changes to make to get VCs excited about putting money in. And so that's good for you. Right? The second level is at a deeper and higher level at the same time. It is for venture capitalists who have given a seed round to a company a space company. And that has gone on for a little while, 6 months, a year, something like that. And it is time, as COVID has made it, to double down or get out. Those are pretty much the choices, right? It's time to invest further in a thing we already know, which seems to be the direction VCs are going in right now. They don't seem to want to look at new things or stop, just kill the project. And so the good news is, in that situation, there's a lot more going on. There's more meat for cold star experts to get in and analyze, right? You're going to have processes in place, whether they know it or not. We'll be able to flowchart those and maybe accurately document them for the first time so we can get some kind of value chain going in the organization. We'll be able to test whether the leadership is the right group of people or whether you're missing something, the strategic direction, the business model, all this stuff. So if this sounds interesting to you, reach out to us. You can email me at jason@coldstartech.com or just connect with me and message me on LinkedIn. That's probably the best way to do it. And I am excited to talk to you. The kind of transformation that we're able to offer here is beyond anything you'll see out there. And as a VC, this will save you so much time and energy, right? Like if you're a VC and you've got 100 companies to look at, you've got 3 days a year to look at each one maybe, right? That's not really good enough, is it? Wouldn't it be better to have experienced expert space people who understand space, right? Look at this investment and tell you, here's a grade. Right? Here are several grade areas. Is this thing ready to pour gasoline on the fire, or is it just going to go up in smoke? This is Jason Kanigan from Cold Star Tech. Let's get back to the interview. So you mentioned, and I'm glad you put this on our Google Doc here, being a research assistant at the Gund Institute of Ecological Economics, because that did not jump out at me, and it's clearly important for you and your experience. So I want to hear more about that. Let's clear up, first of all, what ecological economics is. I'm thinking farming, based on what you said, something to do with that. And then tell us a little bit about what you did there.
Yeah, I think it's an intentionally paradoxical name. So I was working with another WashU alum, Jillian Galford, and the Gund Institute of Ecological Economics specifically studies the relationship between climate change, agriculture, and the economy. So it was a combination of GIS specialists like geographers, also like remote sensing people. So that's what Jillian was there for, and that's why I ended up working with her. And also actual economists, people who made predictions about how the economy was supposed to perform. And they were using all of our data from doing like field surveys and remote sensing as input for their economic model. So yeah, that's kind of the weird name they came up with.
Yeah, remote sensing. So there could be a tie-in with space here. Okay, and your experience there was?
Oh yeah, so I was a research assistant for Jillian. We were looking at remote sensing data over Malawi, a country in sub-Saharan Africa. We were teamed up with an economist from Colombia. First name is Hope, I'm forgetting her last name, but she was great. And she was working with the Malawian government. She had all of this survey data about people who had received this farming subsidy. And the government was wondering, did this farming subsidy actually work? We put a lot of effort and had a lot of international funding from different sources to give people seeds and manure and fertilizer. Did that actually improve crop yields? So Hope kind of had the economic model based on all of the input funding from international sources and what local economists on the ground were saying. And we were looking at the farms from orbit and seeing if we could see increased yields based on the enhanced vegetation index. It's just a measure of like how steep your edge is for like red band to near infrared band.
Okay. Does that experience help you with your work today?
Yes.
Satellite imaging.
Yes, it does.
Okay.
Yeah.
Now you've worked at BlackSky since last fall. So I think that's long enough to know your way around, right? Without getting into anything that's covered by security or compliance issues and that. What has that been like? What's your role there like?
Yeah, so my nominal role is image processing engineer, which means that we have a lot of tools and algorithms built out to do all of the things that you kind of get for free when you download NASA data. So if you, for the Gunn Institute of Ecological Economics, we were using Landsat data. And Landsat data comes radiometrically calibrated, and there are masks that tell you what's water and what's not water and what's urban and what's not a field. And we could use that information to do a lot of data analysis for the cropland. At BlackSky, we're kind of building all that stuff out ourselves. So that is one of my roles, to kind of help build some of the algorithms that georeference an image or determine, if this is water or not, or another person is writing algorithms to determine what are clouds in our images, how do we mask for that? Kind of all those things that Landsat has this long heritage of doing. And my most recent project, I guess, has been kind of understanding image quality, which is an interesting question, and ended up tying into some computer vision, like what is a good image viewed on a computer screen? It was good for my algorithm, but is it good for an analyst to look at? So kind of developing some metrics to understand that and help us improve our images over time by going back and kind of adjusting these algorithms.
Okay, so there's some interesting data science, machine learning applications there I'm hearing, and quality. They're very interesting. This is a data science and process engineering company. I've got one of the top data scientists in the world working for us. He works, his day job is with a major North American company he doesn't want to mention, but I know enough about data science to walk around the edges and also to keep away from it. I can bring him in. So it makes me ask good questions around it. So I didn't realize when we first connected, months ago, whenever that was, and booked this, that you were in the data science field. It's a reading through though, I was like, oh wait, Brené's really in this. So thinking about data science, how have you evolved your process or checklist on deciding your investigative approach? And I think this goes back to the research question a little bit. I think the two are connected.
Does. Yeah, so I'm not formally trained in data science, but that obviously is a big part of my role right now. We have a great data analytics team out in Hardin, Virginia, that does a lot of the deep, like, machine learning, like human marked images that they process through amazing algorithms. So I'm also kind of on the periphery in that, but learning more about data science and using it for this job has really changed my process, and that iterative thing that I mentioned earlier about just kind of going back and forth, looking at the data, looking at it again with fresh eyes, looking at correlations and trying to understand that has really become the centerpiece now with the coding skills and the data science skills that I've gotten from this job. I think definitely now the first step is to data mine and to look at the raw data, look at correlations, get first impressions, and then kind of decide where to go next. And using those tools from data science has definitely improved that process, I think.
Okay. Are you doing more unsupervised learning or supervised learning?
I think we're doing a lot of supervised learning. There are people who manually classify a lot of the images, and then we use that for supervised learning algorithms.
Okay, yeah, which again lines up with the research question. It's like, what are we asking here? Yep. For folks listening who have never had to do this before, it's like, what do you mean you're asking, what are we asking? It sounds so simple, but yeah, when it's time to get clarity on these sorts of things, it is not always easy to know what we're asking or what we want to find out or what we think we want to find out, because as you found out initially, you can have an idea of the question you want, and then the data brings back something and you're like, huh, wait, no, I need to unpeel the onion layer a little bit more here. So you've proceeded towards your doctorate at a couple of organizations and that. We have a lot of graduate students who listen to this show or watch this show. Do you have any advice for them about the question of whether they should go forward towards their doctorate or not? What have you learned and experienced from what you've done?
Yeah, without going into too much detail, there were a lot of different personal reasons, involved in me deciding to not, end up finishing my doctorate and just kind of going for the master's instead.
Mm-hmm.
I think my advice to my past self would have been to actually make sure to take some time and like explore everything that's available before committing to that grad program. So I had a job at the Gun Institute. It was really interesting, and I learned a lot, and was getting closer and closer towards like more coding and data science, and as well as remote sensing. But I have a passion for planetary science, and I wanted to learn more. But I think what I honestly should have done before that was to say, hey, I'm at this job. What other jobs could I get with this planetary science background? Where else could I go? Is a doctorate the only option that I have right now? Or could I get these skills someplace else? So yeah, I think looking at, if you are in the sciences at all, looking at data analyst and research analyst jobs and internships, you might be surprised at what companies need data analysts and research analysts. You might find that the work is actually really interesting, and that you don't necessarily want to, devote your time to a doctorate where you do study one thing, pretty intensely. And it can be harder, to go out and explore what else is out there. I would also recommend to everyone to just learn a coding language. Just pick one. Python is what I use right now. At Gund, I used R. I think at Cornell, I did MATLAB for a little while, but Python is kind of what's popular right now, and it's kind of what I settled on. So yeah, those would be my two things: learn to code and explore what else is out there, because a doctorate is a great option and opportunity. But there are so many other cool things out there, and you owe it to yourself to go explore. Cool.
Okay, Bryne, if we were to hit the fast forward machine on your life, which we don't, maybe that's a graphic way of putting it, but if it's like 10 years from now, and you're talking to yourself, what do you think your focus is going to have been, or and what do you think you'll be doing in the space field?
That's a really good question. I think about that a lot.
Good.
Because the space industry is moving so quickly and so fast. I really think that data science, data analysis, and coding are going to be huge factors in the future of the space industry. And I would like to continue staying with that. I love lab work, and doing chemistry and things like that was great. But I think that the modern space industry right now, I think companies like BlackSky, our competitors, Planet, Digital Globe, Esri, everyone like that, data analysis and coding are the two really big skills that they're looking for, and the skills that they need to kind of get these constellations up and running and do really amazing science from space. Maybe someday someone will send a fleet of satellites to Mars or something. I don't know. That would be great. That would be my dream job, analyzing data from a fleet of satellites around Mars or Titan or any planetary body. Okay,
so bring on the exotic planetary data so that Bryne can learn something. Awesome.
Yes.
All right. Well, my guest today has been Bryne Hadnott. She is with BlackSky, and I appreciate you being here.
Thank you so much for having me.
Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Star Project. If you want me to send you new episodes of the Cold Star Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB. That's short for Make Space Boring, which is what we're all about. And drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Star Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks for listening, and I look forward to talking to you soon.